Okay, let's start. Now, Laplace transform. The word is Laplace transform. So, what is the meaning of transform? Just to forget about what is Laplace Laplace. Now, transform. What do you mean by transform? Means what? You whenever you say transform, that means you are transforming something to. Means you are changing something to something. So now you have already know about the differentiation, is it not? Obviously, you know the differentiation. Say, if I write d dx of, say, sine x, if I am writing d dx of sine x, so what is the d dx of sine x?
Cos x.
Cos x. Yeah. d dx of sine x is what your cos x. So this ddx, this is the what? Differential operator, is it not? This ddx is nothing but the differential operator. Now you are operating something over sine x. So what is that something? That is differential operator. So you are changing this function sine x to other function. That is what? Cos x. By what? By using what? This also you can say the transformation. So this is nothing but operator, differential. This is called differential operator. So you are operating this differential over what? Over some function. Then that some function is changed to what? To some other function. So that is the transformation. So in that way. So now come to the Laplace transform. Now, Laplace transform is nothing but, suppose you have a function f of t. Suppose you have a function f of t. And this f of t, this function f of t exists for all value of t when t is greater than equal to 0. So this f of t, this ft will not be valid for t less than 0. So suppose we have a function f of t and that function is valid for t greater than is equal to 0. So this condition must be there. So Laplace transform will not define for t less than 0. So we need to consider a function such that that function will be valid only for what? T greater than equal to 0. T is the variable. Then the Laplace transform of f of t is denoted by L of L curly bracket f of t. This is the notation. This is the notation of what? Laplace transform of what? F of t. And it is defined as L of f of t is equal to, this is the definition, 0 to infinity e to the power minus pt into f of t dt. Try to understand. L of ft, the Laplace transform of ft is defined by what? By this integration. What is the integration? Integration, limit of integration is what? From 0 to infinity e to the power minus p, small p into t into f of t. F of t means what? This function f of t. Just simply to e to the power minus pt, just you multiply f of t. And then you integrate this whole part. Integrate this one and then you put the limit, you will get. So after integration of this with respect to t, and then after putting the limit, you will get a function of what? You will get a function of what? P, because p is there. You will get a function of p. So try to understand here. The function name is what I have written in terms of what, capital F of t. So this name cannot be written after finding the Laplace transform of this capital F of t. After finding, just to give other function, say I have given a small f of p. So here capital F, so you can't write again capital F here. Otherwise, f of t and f of p, there will be no difference. So that's why, because after integration, you will get some other function. So just to give other name other than this one. That means you can't use again capital F here. So in general, how will you we denote? If capital F is used, then a small f of whatever we, if p is there, then you p. In some book you will find in place of p, in some book you will find that p will be written in terms of s. Okay, in p, in place of this small p, in some book you will find it is written s, a small s. So don't confuse with that. You can take other variable also. In place of p, you can write u also, whatever. But after integration, it will be a function of what? F of that p, whatever you have considered. So this definition must you have to remember while finding the Laplace transform, where p is the parameter. So this Laplace transform of f of t is said to exist if this integral exists. That means if this integral, if you can integrate, and after integration, if you are getting some particular function, then only you can say that what the Laplace transform of what f of t exists. And after integrating, if you are getting say infinity, after putting the limit, so does the Laplace transform of f of t exist in that case? Obviously no. In that case, obviously the Laplace, if you are getting the value of f of p is infinity, it means after integration of this part and after putting the limit, if you are getting the value as infinity, so obviously this integral does not exist, and so in that case the Laplace transform of f of t does not exist. So that is, so Laplace transform of f of t is said to exist if the above integral converges for some value of p, otherwise not. That means you are getting some value, if you are getting, that means if you are getting some particular function, then only the Laplace transform of f of t exists, otherwise not. And this, after integration, whatever you are getting this f of p, so this is called Laplace transform of what? This is called Laplace transform of f of t. This is called Laplace transform of this function f of t, whatever you have got. So as already I told, in some book you will find in place of p, s is written. So this can also be written as like this, same thing. L of means Laplace transform of f of t is nothing but 0 to infinity e to the power minus s into t into f of t dt is equal to what? So after integration, you will get a function of what? S, f of s. So you can write like this also. Is that clear? Anyone have any doubt regarding the definition of Laplace transform?
No,
Huh?
sir. No, sir.
Okay. So next you see,
No, sir.
sometimes see, as I already told you, here if capital F is used while finding the Laplace transform, so after finding the Laplace transform, I told you don't use capital F again. So if you are using capital F, suppose in place of F you are writing capital F, then how will you write? You can't write simply capital F, you have to give one bar. So you must have some difference in the name of the function. So that is here, it has been written. That is it. Okay. Now see linearity property. So obviously you know that part. That is just similar to your integration or differentiation part. So suppose you have this function. What? Sorry. Suppose you have this function C1 into ft plus C2 into gt. Your question is to find the Laplace transform of this whole function. That means this is a linear combination of what? ft and gt. C1 ft into C2 gt. So here C1 and C2 are constant. So like in case of differentiation, simple. In case of differentiation, suppose if you have ddx is equal to suppose a into f of x plus b into say g of x. Then how will you differentiate it? Whether differentiation or integration, same thing. So what? So a is constant, so a will be outside. Then what? ddx of what? What? F of x. ddx of what? F of x plus again plus is there, then plus b is constant, take it outside. Then what? You will differentiate what? Differentiate gx. Is it not? You differentiate g of x. That's okay. So this is nothing but the linearity property. Same thing here also you have to do. Here C1 and C2 are constant. So simply you need to find the Laplace transform of this ft and Laplace transform of what? Gt. Then what? How will write? C1 Laplace transform of ft, C1 Laplace transform of ft plus C2 into Laplace transform of what? Gt. If it is plus, then plus. If it is minus, then minus. But not for product and division. Okay, only for plus and minus. That is the linear combination property. Is that clear? So proof is very simple here. So what is the definition? So this whole part, if I will consider capital F of t, so according to the definition of Laplace transform, so Laplace transform of this f of t is equal to what? Integration 0 to infinity e to the power minus pt into this what? ft. And ft means what? C1 ft plus C2 gt dt. Is it not? Then C1 and C2 are constant. So just you break into two different integration. So what will get? C1 is outside, integration 0 to infinity e to the power minus pt into ft dt plus C2 is constant of integration. Constant. Take it outside of integration 0 to infinity e to the power minus pt into gt dt. So this is nothing but what? This is nothing but the definition of what? Laplace transform of ft. This is nothing but the definition of, from the definition of Laplace transform, it is what? Laplace transform of gt. So it's proof. That is very simple. You can understand that. Now we'll find some, and this is very important. And you must have to memorize also this. While solving the problem, you need all these formulas. As a formula, you must have to remember all this. Okay, what is the Laplace transform of 1? What is the Laplace transform of t to the power n? So this all you need to memorize, because we need to use this one while finding the Laplace transform of different functions. Okay, so first we need to find the suppose Laplace transform of 1. So it is Laplace transform of 1 is 1 by p, where p should be positive. This is the condition. So we need to show that Laplace transform of 1 is 1 by p. So let's see. So according to the definition, f of t is how much it is? 1. So from the definition of Laplace transform, it is what? 0 to infinity e to the power minus pt into what? Into ft. And f of t is what here? F of t is what here? 1. So just you write 1. So e to the power minus pt into 1, e to the power minus pt. And what is the integration of e to the power minus pt? So p, consider, because you are integrating with respect to t, so consider p as constant. So e to the power minus pt by minus p, because minus is there, negative is there. So negative e to the power minus pt by p. Then you put the limit 0 to infinity. So e to the power minus infinity is what? 0. So first term will be 0, and then minus is there. So minus minus become plus, and then you put 0. So e to the power minus 0. E to the power 0 is what? 1. So it is 1 by p. বুঝি পাইছেনে নাই? এটু limit put করা পিছত. Did you understand how we have got? Because if you put infinity, so e to the power minus infinity, the value is how much? The value is 0. So first, after putting infinity, if you put infinity, so it will get 0. Then minus, but here minus is already there. So minus minus become plus. So 0 if you put, so e to the power 0 is, means in place of t you are putting 0. So ultimately e to the power 0, that is 1. So 1 by p. So that is 1 by p. So it is what? 1 by p. Is that clear?
Yes, sir.
Yes, sir.
Yes, sir.
Okay.
Yes, sir.
Next you see. Now Laplace transform of t to the power n, where n is any positive integer. Okay, where n is what? Any positive integer. So Laplace transform of t to the power n is what? This is factorial n divided by p to the power n plus 1. Factorial n by p to the power n plus 1. So that is a very simple one. So let's see here. Laplace transform of t to the power n. So t to the power n, so ft is what here? Capital Ft is what? T to the power n. So from the definition of your Laplace transform, what you can write? E to the 0 to infinity, e to the power minus pt into ft. Ft is what? Pt. Ft is your t to the power n dt. So now what I have done, now just you put pt is equal to x. So then your limit of integration will also change, and this variable dt also change. Dt in terms of dx will come. So if you differentiate both sides, so p dt is equal to dx. So dt is equal to dx by p. So e to the power minus x. Now in place of t equal to what? X by p. So t in place of t, this is x into, okay, this is x into sorry, what is pt? Sorry, not this is, okay, e to the power minus pt is equal to what? Pt is equal to x we have considered, so it will be e to the power minus x. So e to the power minus x into, now t means what? X by p. So x by p whole to the power n into, now dt is equal to what? If you differentiate both sides, so p dt is equal to what? Is equal to dx. So dt is equal to what? Dx by p. Now you have to check limit of integration, you have to check. So now see that will remain same, because when t is 0, here t is what? T is 0. If you put t equal to 0, you are getting x equal to 0. If you are putting t equal to infinity, you are getting x equal to infinity. So limit of integration will remain same. So now see here, this one, this part. What is that one? 0 to infinity e to the power minus x into x to the power n into, now see here denominator, in denominator if you see, denominator is what? 1 by p to the power n into, again 1 p is here, no? So if you multiply, then what? You will get p to the power what? N plus 1. So this p to 1 by p to the power n plus 1, I have taken outside of integration, because you are integrating with respect to x. So now it will be 0 to infinity x to the power n into e to the power minus x dx. Did you understand this part? Now, if you remember, I have taught you in second semester, in case of reduction formula, the integration of this part, the integration of this in reduction formula, if you remember, so you can use directly. So the value of this integration is nothing but gamma n plus 1. The value of this integration is how much? This the value of this integration, this one. The value of this integration, that is your dx here. The value of this integration, that is your gamma n plus 1. And how to write in terms of factorial? So that will be what? Factorial n. One less, then if you want to write in terms of factorial, then it will be factorial n. So only you can write the gamma function in terms of factorial only if it's a positive natural number or positive integer, you can say. Otherwise, if it is a rational number, you can say fraction number or rational number. So you can't write in terms of what? In terms of your factorial. Then you have to write in terms of gamma. So that's why I have written. So if this n plus 1 will be a positive integer, then you can write in terms of factorial. If it is not a positive integer like a fraction number, then you need to write in terms of gamma function. That's all. So ultimately, just I have written here, I have given here already. If n is a positive integer, then gamma n plus 1 will nothing but a what? Factorial n. So already I have considered here n is a positive integer. Okay, here already I have considered n is a positive integer. Then gamma n plus 1 will become what? Factorial n. And so Laplace transform of t to the power n becomes what? Gamma n plus 1 is what? Factorial n divided by p to the power n plus 1. That's prove our result. See, so simple. So only thing is what? You need to know how to integrate. So now at this level, I can't I can't go to explain how to integrate that one, because that you have already got in second semester itself. Now similarly, now see here, from this you can find the Laplace transform of any power to t. Now if you put t equal to 1, n is a positive integer, no? So put n equal to 1. So Laplace transform of t will be how much? Factorial 1 by p to the power what? 1 plus 1, because n is 1. So factorial 1 is what? 1, and p to the power 1 plus 1 is what? 2. So 1 by p square. Similarly, you can find Laplace transform of what? t square. So this time it is what? N is equal to 2. N is equal to what? 2. So what? Factorial 2 divided by p to the power 2 plus 1. And so factorial 2 is how much? Factorial 2 is how much? It is 2 only. Divided by p to the power 2 plus 1 is what? 2 to the power 2 by p to the power 3. Similarly, if you want to find t to the power 3, so factorial 3 by p to the power 3 plus 1. That's okay. Just you simply put the value of n here. So in that way, you can find out the value of Laplace transform of what? T to the power n. Now next is your Laplace transform of e to the power at. Okay, Laplace transform of what? E to the power a into t. A is a constant. So the Laplace transform of e to the power at is nothing but 1 by p minus a, where p is greater than a. The value of p should be greater than a, otherwise this becomes negative. If p will be less than a, then p will be becomes what? Then this part will become negative. So this cannot be negative. So that's why the condition should be p should be greater than a. And also p cannot be equal to a, because if p is equal to a, so then this becomes the denominator becomes 0. So this part does not exist, and so the Laplace transform of e to the power at does not exist. So that's why the condition for existence for this Laplace transform of e to the power at is what? P should be greater than a. That is the condition. So now use the definition of Laplace transform. That is what? 0 to infinity e to the power minus pt into ft. Ft is what here? Ft is here what? E to the power at. That's simple. So base is same. So power should be added because you are multiplying e to the power minus pt into e to the power at. So base is same. So just add the what? Power. So you will get e to the power minus p into p minus a into t dt. So that is p and a both are constant. The simple integration. So it will be what? Minus e to the power minus p minus a into t divided by p minus a. Now you put the limit of integration. If you put infinity, so this becomes e to the power minus infinity. So that becomes 0. The first part becomes 0. If you put 0, then what? First term becomes 0. So minus is outside here. Just I'm taking outside minus. This minus I'm taking outside. So 0. Then what? Upper limit minus lower limit. So upper limit, if you put 0, you have got 0. Then you put 0. So e to the power 0 is how much? 1 by p minus what? P minus a. Then if you remove this minus, so minus 0, 0, minus minus plus. So that becomes 1 by p minus a, if p is greater than a. So Laplace in that way, the Laplace transform of e to the power at is what? 1 by p minus a. P should be greater than a. Similarly, in the similar fashion, we can find out the Laplace transform of sine of at, where a is constant. So Laplace transform of sine of at is a by p square plus a square. P should be positive. P is greater than 0. So very simple. Just to see. If you use the definition, then you can understand that part also. Very simple. So first, 0 to infinity e to the power minus pt into sine of at dt. So u into v. Just you product formula. Use the product formula. Integrate it. You will find this one. Whether you know the integration or not. Product formula of integration. So use that one here. Product formula of integration. You will get this one, and then you put this limit of integration. You will get this result. Similarly, you can find the Laplace transform of cos of at. That will be p by p square plus a square. P is greater than 0. The same thing also you have to do here. If you need to prove this one, the Laplace transform of cos of at is your p by p square plus a square. Then simple. Use the definition 0 to infinity to the power minus pt into ft. Ft means cos of at. Then use the product formula of integration. You will find this one, and then put the limit of integration here. You will find this one. That is very simple. So as a formula, you need to remember all this, because we are going to use directly while finding the Laplace transform of different problems or different functions. Then Laplace transform of sine hyperbolic. This is sine h is there, no? So this h for what? Sine hyperbolic. So obviously you have already come to know about what is a hyperbolic function. But again, just I am giving the hint for that one. Sine of h, a t, sine hyperbolic at is nothing but your e to the power. This is the definition of hyperbolic function. Sine hyperbolic, e to the power at minus e to the power minus at by 2. Similarly, for cos hyperbolic at, cos hyperbolic cos hyperbolic at, that will be your e to the power at plus e to the power minus at by 2. This all these things you have already got that one. So in order to find out the Laplace transform of sine hyperbolic at, we need to use this one. This the value of this means the value of sine hyperbolic at in terms of exponential we need to use. So according to the definition, so sine Laplace transform of sine hyperbolic at is what? Your a by p square minus a square, and the value of p should be greater than what? Absolute value of a. The value of p should be greater than absolute value of a. So from the definition of Laplace transform, it is sine hyperbolic at 0 to infinity e to the power minus pt into sine hyperbolic at into dt. So sine hyperbolic at, that is what? E to the power at minus e to the power minus at by 2. Just I have substituted here. Then what I have just separated in terms of 2 integration. So just I have separated in terms of 2 integration. And then simple integration. If you integrate this one, you will get what? This one first. This one. If we integrate this one, so you will get what? You will get minus e to the power minus p minus a into t by p minus a. P and a is constant, so p minus a is constant. 0 to infinity. So if you put this limit of integration, you will get 1 by p minus a first. Then again, if you integrate this one, you will get what? Minus is there already. So e to the power minus p plus a by p plus a. Again, if you integrate, if you put the limit of integration, you will get 1 by p plus a. And this minus is this one. So ultimately, if you simplify, you will get what? A by p square minus a square. Similarly, for Laplace transform of for cos hyperbolic at, you will get p by p square minus a square. In the same in the similar fashion, you will get that one. Okay. So this all whatever you have got 7 here. So as a formula, you need to memorize it. Okay. So